The graph of f of x equals log base b of x is shown below as long as the base is, or when the base is greater than 1, and then when the base is in between 0 and 1. So because log base b of x and exponential b to the power of x are inverse functions, they're showing them here together. And because they're inverses, they're a reflection over that diagonal line. So the log function are the red ones there. So the log functions have vertical asymptotes. So what happens is they're going to run along this vertical asymptote, and nothing is ever going to be graphed to the left of wherever that vertical asymptote is. So if your base is larger than 1, so like log base 2 or log base 6 or log base 5, when that base is larger than 1, your function will look like this one on the left, and that's what we will usually have. If your base is between 0 and 1, so like log base 1/2 or log base 1/3, it looks like this graph on the right here. But they're still always from the right, or from that vertical asymptote to the right. There's never anything going to be on the left-hand side of these graphs past that vertical asymptote. So right now, because they're not shifted at all, the vertical asymptote is on the y-axis, so the domain is from 0 to positive infinity, or x is greater than 0. So for these graphs, the domain, because it's always to the right of that vertical asymptote, is always going to be from the vertical asymptote to the right. So vertical asymptote to positive infinity. The range for these guys is always going to be negative to positive infinity. It's always going to be continuous in this vertical direction. So for log functions, you can always count on the domain being from that vertical asymptote to the right, and the range always being negative to positive infinity. And just like all of the other functions we've talked about, once we start adding in values or adding an a in the front, it will change the look of our graph, but it's still the same idea. If a is larger than 1, it will be stretched. If a is smaller than 1, our graph will be compressed from the pictures above, or the parent functions above. It will be reflected if a is negative, so it'll go the other direction. And your h parameter controls your horizontal shifts, which means it determines the domain in your vertical asymptote. The k parameter controls the vertical shift of how it's moving up and down. So to find the vertical asymptote for log functions, all we do is solve for this part inside the parentheses. That gives us the vertical asymptote and will give us the domain. So if we did that, here, if we said x minus 4, set it equal to 0, our vertical asymptote would be at 4. We would subtract the 4 over and go from there. So like if you guys were graphing this, vertical asymptote would be at positive 4, and your graph would kind of go to the right there. So the domain is going to be from 4 to positive infinity. It's always from that vertical asymptote to positive infinity. So for number 2, if we set 5 minus 2x equal to 0, we subtract the 5 over, get negative 2x equals negative 5, divide by negative 2, and get x equals 5 halves. So vertical asymptote at 5 halves, which means the domain must be from 5 halves to positive infinity. You can make it 2.5 if you wanted a decimal. but that is it. Find the vertical asymptote, you know the domain. So for number 3, the vertical asymptote would be at -2. Let me write that a little neater. Because you guys would set x plus 2 equal to 0. So that means your domain would be from 2 to positive infinity. If you know the vertical asymptote, you know your domain. That value to positive infinity.